Good morning, students. Today, let us discuss a topic in the chapter Waves. In the chapter Waves, initially let us discuss about the two types of the waves. Those are longitudinal waves and the second one is transverse waves. You know what are longitudinal waves? In the longitudinal waves, the vibrations of the particles are parallel to the direction of propagation. But in transverse waves, the vibrations of the particles are perpendicular to the direction of propagation. Remember, students, in longitudinal waves, vibrations of particles are parallel to the direction of propagation. But in transverse waves, vibrations of particles are perpendicular to the direction of propagation. A longitudinal wave is formed with compressions and refractions, but a transverse wave is formed with crest and the trough. Now, let us take the transverse waves. I will write the displacement expression for the transverse waves. The displacement y is equal to a sine omega t minus kx. You can also take it as kx minus omega t also. Now here, capital A represents the amplitude of the wave, amplitude, and omega represents the angular frequency. It is also called angular velocity. And k is called as propagation constant. Remember the terms? Amplitude. A is amplitude, omega is angular velocity or angular frequency, and k is the propagation constant. Angular velocity omega is equal to formula 2 pi by t, and propagation constant k is equal to 2 pi by lambda. You know, here capital T is called as a time period and lambda is called as wavelength. Time period and wavelength. Now we will explain what are amplitude, what are wavelength, and what is time period. See, here let us imagine that it is a transverse wave, and in the transverse wave it is called as crest, it is called as trough. If the wave completes one crest and one trough, then we can say that one oscillation is completed. In the completion of one oscillation, the wave is traveling to certain distance. This is the distance traveled by the wave. This distance traveled by the wave in one oscillation is called as wavelength. Remember, distance traveled by the wave in one oscillation is called wavelength. Next, to complete one oscillation, the wave is taking certain time. This time taken by the wave to complete one oscillation is called as time period. Time taken to complete one oscillation is called time period. Now we know the time period and also wavelength. If you know these two terms, then you can find the wave velocity. Now let us find wave velocity. Wave velocity omega by k. Ratio of angular frequency and the propagation constant is called as wave velocity. Wave velocity is equal to 2 pi by t by 2 pi by lambda. 2 pi gets cancelled, then v is equal to lambda by t. Next, one more thing. Here, you see carefully, here 1 by t is there. Here 1 by t is called as frequency. Frequency. Now let us define what is frequency. In one way we can define frequency as a reciprocal of time period. In the another way also we can define frequency. That is the number of oscillations completed in 1 second. Number of oscillations completed in 1 second is called frequency. The units of frequency is hertz. Hertz. Now, in place of 1 by t, you can write mu. Then v is equal to mu into lambda. It is the expression for velocity of the wave. But you remember that the waves can travel in different types of medias like solids, liquids and gases. In all the medias the waves can travel. Now let us take the propagation of the wave in a solid medium. Solid medium. Further, let us take a string. A string is nothing but a thin wire. And the string is fixed between the two ends. Then the string is plucked and then released. Then what happened? A wave is produced in a string like this. When the wave is traveling through the string, that wave definitely will have certain velocity. To find the velocity of the waves through the strings, we use the formula V is equal to square root of T by mu, where T is called as tension in the string. Tension. And the formula of P is equal to mg. The tension and the force have same units and same dimensions. The unit of tension is newtons. Force is also having same newtons, SI units. And the dimensional formula of force and tension both is mLT power minus 2. It is the dimensional formula. Next, where mu is called as linear density. Linear density. Linear density is nothing but mass per unit length. Mass per unit length is called as linear density. SI units are kg per meters. Kg per meters. From this you can write the units of velocity as SI units of meters per seconds. So remember students, tension and force have same units and same dimensions. That is, units are newtons and dimensions are mLT power minus 2. But the linear density means mass per unit length. The SI units are kg per meters. And the units of velocity is meters per seconds. You can write the dimensional formula of velocity also as mLT power minus 1, or you can write it as m0 LT power minus 1. It is the dimensional formula of velocity.